Hi students, this is Mr. Yao. Today we are going to talk about 6.8, where we will combine everything we have learned about sequences and do some sequence comparison. So let's have a look. Here are all the sequences we have learned, arithmetic and geometric. First, our patterns. We have been talking about common difference and common ratio. That's also why we're using letter D and letter R. And because we're doing common difference for arithmetic, of course, we can get those from adding or subtracting the same number. And since the common ratio for geometric, we are multiplying or dividing. And yes, even though we have only been using multiplication inside the formula, technically we can also do division. Like when we're dividing by 5, it's also multiplied by 1/5. That's why both operations would actually work for geometric sequence. Next, finding the pattern. This is something you have done, it's just we have never used mathematical way to talk about it. So for arithmetic, you are going to take any term and subtract the one before it. So a sub n minus, of course, the one before it is a sub n minus 1. Then for geometric sequence, in order to find a pattern, you are going to take any term and divide the previous term to get the common ratio. So a sub n divided by a sub n minus 1. Something I want to emphasize on, especially in this lesson, make sure when you're checking the patterns, you are checking all given pairs. That is to ensure that the whole sequence actually follow the same pattern. Because there are many sequences, they might look like they follow a certain pattern at the very beginning, then suddenly in the middle they changed. Next, recursive formula. You can see they both need to have a sub 1 in the beginning because that is part of the formula. For arithmetic, we are adding a d on the end, and for geometric, we are multiplying by an r on the end. Next couple things. Explicit formula, a sub 1 plus n minus 1, because there are n minus 1 gaps times d. And geometric is a sub n equals a sub 1 times r to the n minus 1 power, also because we have n minus 1 gaps. To identify the pattern, especially in the formula, for this, if you simplify it, you're going to need to distribute to multiply, so a sub 1 plus d times n minus d. And you can see in order for you to find a d, since the d and the a sub 1 is going to be combined, the only place to see the d is right in front of the n. So for example, like 2n, then that 2 is your d, or negative 5n, that negative 5 is your d. Next, r. Since we have two numbers being multiplied together, r is the one that actually has an exponent. Next question is something we have done before, we have discussed before. Since when we talk about both, when we learn about both equation sequences, we have done an exploration. Like the a sub 1 and a sub 199, we know we need 198 in the middle. That's why we have n minus 1. Because we always need to get from the first term to the nth term, and there are n minus 1 gaps, or n minus 1 common differences, or n minus 1 common ratios. Lastly, this is the only thing that's actually new to the lesson. If you graph a sequence on in a coordinate system, let's say you have a sub 1 as 1, let's say you have a sub 1 as 1, and you have a sub 2 as 4, and a sub 3 has 7, you can kind of see they will form a linear straight line. That's why an arithmetic sequence is like a linear function, which typically is y equals mx plus b. I'm just using function notation to put f in the front. And since to make the comparison, our equation doesn't have x in there, I changed the x into an n. So mn plus b, which is like dn, then have these numbers on the end. So our slope is basically the d. Next, exponential. Let's say you have same idea. Let's say you start with 1, 1, and then at 2, let's say is actually a 3 to the nth power. Well, then it's got to be at 2 is going to be at, well, at 1 is going to be at 3. And then at 0 is at 1. At 2 is going to be at 9. Then you can see it's growing way faster. So if our a sub 1 is, let's say, 1, and a sub 2 is 3, a sub 3 is 9, that would be what this looks like. It's an exponential graph. So I made a typo on your notes. This should be a geometric sequence is like an exponential function. And this is something we have learned in Unit 4, a times b to the nth power, which almost looks exactly like the explicit formula for a geometric sequence. And that is why the b, the base, is like our r, the common ratio. So that means whenever you see an arithmetic sequence, it's going to be a linear function. And if whenever you see a geometric sequence, it's going to be an exponential function. Now let's move on to talk about some examples. There are quite a few things to do for these first 4 examples. You're going to need to decide the sequence type, and you're going to need to decide if it's the function type, and afterwards, if it is an arithmetic or geometric sequence, you should be able to find the recursive and explicit formula and find some specific terms. So for this one, 5 to 8, I'm adding 3, 8 to 11, adding 3. And remember to confirm that it is the sequence type, we are going to need to check for every single pair of numbers. In this case, since we're adding the same number all the way, that's going to be arithmetic sequence. And for the function type, arithmetic is going to be linear. Then that means we can find our recursive formula. A sub 1 is 5, and our d in this case is a 3. So a sub 1 is 5, and a sub n equals a sub n minus 1 plus 3. Explicit formula, a sub n is 5 plus n minus 1. There are n minus 1 common differences, so times 3. Distribute, we're going to get 5 plus 3n minus 3. Final answer, a sub n equals 3n plus 2. Make sure you simplify that. And for a sub 0, you can use the sequence to trace back, or you can just plug in. So a sub 0 is basically means n is currently 0. 3 times 0 plus 2 is going to be a 2. A sub 31, 3 times 31 plus 2 is going to be a 93. Next, example 2. You should be able to notice that is by multiplying by a negative 3 all the way through. So geometric and exponential. A sub 1 is negative 5, and a sub n equals a sub n minus 1 times negative 3. Explicit formula, a sub n equals negative 5 times negative 3 to the n minus 1 power. A sub 0 is basically tracing back. So negative 5 divided by negative 3 is going to be a positive 5 over 3. And a sub 19, I'm going to plug it in. So it's going to be negative 5 times negative 3 to the 19 minus, so negative 5. 19 minus 1 is basically 18. So I'm going to type in the calculator. That is going to give me, negative 5 times negative 3 to the 18th power. It's going to give me a pretty big number, negative 19371024445. And since that's not the answer that our calculator gave us, we can totally keep it. Or if any question asks you to write that into scientific notation, scientific notation requirement is you gotta get the decimal point to right there, meaning you only have 1 digit in front of the decimal point. So that means we need to get it here from all the way from the end. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm gonna need to move my decimal point 9 times. That's around 3 decimal places. 1.937, and since I moved my decimal point to the left 10 times, it's going to be 10 to the 9th power. Even though your calculators may show you the scientific notation that shows as like E9, you can't write E9 on paper because that's basically a programming language that's showing you on the calculator. On paper, you still need to write it as times 10 to the 9th power. That is example 2. Next, example 3. You can see I'm multiplying by 1/5, multiplying by 1/5 still works, but this right here, multiply by 1/4 and multiply by 4 over 25, that does not work. Neither, since there aren't exactly a pattern that we can easily spot. We can't write a recursive formula or explicit formula. We can either write not applicable or DNE, which stands for does not exist. Either way. And of course, we can't find any specific term since we don't even know a pattern. So NA, D, and E. Next, example 4. This time it's subtracting by 4 all the way. So arithmetic and linear. A sub 1 is 13. A sub n equals a sub n minus 1 minus 4. Explicit formula, a sub n is 13 plus n minus 1 times our D, in this case is negative 4. So distribute 13 minus 4n, that negative 1 times negative 4 is going to be a positive 4. So a sub n equals negative 4n plus 17. Plug in 0, negative 4 times 0 plus 17 is 17, and a sub 44 is going to be negative 4 times 44 plus 17, which is going to be negative 159. That is a sub 44. Next, for example, 5 through 8, it's asking to change between formulas. Meaning, if you see a recursive formula, you are going to change it into an explicit formula. And if you see an explicit formula, you are going to change it into a recursive formula. First one, you see a sub 1 is given, and a sub n and a sub n minus 1. That's recursive formula. It's being multiplied, so that has got to be geometric sequence. I can rewrite into an explicit formula for geometric sequence. 2 times, my r is this number on the end, negative 1/2, so times negative 1/2 to the n minus 1 power. That is example 5. Example 6, you can see it's a plus 6. That means I have a d equals 6. That is an arithmetic sequence. I can write it into an explicit formula. A sub n equals, my a sub 1 is 0, then n minus 1 of the common difference, which is 6. That simplifies to be a sub n equals 6n minus 6. That is example 6. Next, example 7. I can easily identify. Remember, in the table, we said d is next to the n. This whole thing doesn't have any exponents. So, of course, that's not going to be geometric. It's got to be arithmetic. And number in front of n is going to be our d, which is 2. And something to be very careful with, you can't just think this negative 6 is your a sub 1. This negative 6, if you think about the previous few examples, that basically is our a sub 0. So if you want to find a sub 1, you need to plug in 1 for n. 2 times 1 minus 6, which is negative 4. Since this is an explicit formula, the way I know that is because there's no a sub 1 given, and I also don't see a sub n minus 1 in the formula. So this has got to be an explicit one. I need to change it into recursive. A sub 1 equals negative 4, and a sub n equals a sub n minus 1 plus 2. Next, example 8. The number that has the exponent is going to be our r. Then the other number is going to be our first term. So a sub 1 is negative 4, and a sub n equals a sub n minus 1 times 1/8. That is example 8. Next, example 9 through 12. Find explicit formula. These are questions we have talked about in 6.4 and 6.7. We are just kind of relearning them again. First is asking to find a sub 1. And if you look at this whole explicit formula, the only thing I know is there's a negative 7 there. But I don't know a sub 1. I also don't know n. You might be like, I'm stuck. However, there's another piece of information in the question. It's right here. Whenever you are given a specific term, that is basically telling you, hey, now you're going to treat n as 11 and see what that's going to happen. So if n is 11, I'm going to put that into my explicit formula, which is here and here. So now I would have a sub 11 equals a sub 1 plus 11 minus 1 times negative 7. And then you might be like, wait, I'm stuck again. Yes, I do have something like that, but there's nothing I can do. Well, wait and see. I'm going to distribute, or actually 11 minus 1 is just 10, times negative 7 is a minus 70. So I have a sub 1 minus 70, which is a sub 11. And don't forget, you're not just given a sub 11 in the front. You also are given the specific number for a sub 11. This is actually negative 93. If I add 70 on both sides, my a sub 1 would actually be negative 23. Now I know my a sub 1, I can go back and find the full form of my explicit formula. A sub n equals negative 23 plus n minus 1 times negative 7. That is negative 23 minus 7n. Negative 1 times negative 7 is a plus 7. So my final answer, a sub n equals negative 7n. Negative 23 plus 7 is minus 16. That is my explicit formula. Next, example 10. For geometric sequence, you can use the same method, but because it's an R, and sometimes when you do higher power, higher exponent of these numbers, it might get a bit complicated. So for geometric sequence, you are allowed to trace back to find a sub 1. A sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. That is 81. Since my r is 2/3, that means that I'm going forward to multiply by 2/3 to get to the term. Then that means if I'm going backwards, I'm going to have to divide by 2/3. Or in other words, I'm multiplying by the reciprocal number, which is 3/2. So 81 times 3/2 is going to give us 243 over 2. Then keep going, it's going to be 722 over 4, 2,187 over 16, and 6,561 over 32. That's my a sub 1. My explicit formula is going to be a sub n equals 6561 over 32 times my r is 2/3. Make sure you still use 2/3. Even though we have this number, that is not our r. That is r backwards. We still need to use the original r, which is 2/3 to the n minus 1 power. That is example 10. Next, example 11. This question is very similar to example 9. There's only one difference. You are given a recursive formula. But with the recursive formula, you can easily identify your d is 9. So I can still use that to write an explicit formula, just partially. A sub n equals a sub 1, and then plus n minus 1 times my d is 9. That is my explicit formula. Since I'm solving for a sub 1, I'm going to use the specific term I'm given, again, which is 17. So n equals 17, that means a sub 17 is a sub 1 plus 17 minus 1 times 9. I already know my a sub 17 is 118. So I set it equal to 118, then start solving. A sub 1 plus 17 minus 1 is 16. 16 times 9 is 144. That equals to 118. Subtract 144 on both ends. My a sub 1 would actually be negative 26. Now I can use that to find my actual explicit formula. A sub n equals negative 26 plus n minus 1 times 9. So negative 26 plus 9n minus 9. Final answer, a sub n equals 9n minus 35. There's my explicit formula. Lastly, example 12. I'm given a sub 4, a sub 1, a sub 2, a sub 3, and a sub 4. My r is, so if I'm going this way, is multiplying by negative 3/4, going this way. And my a sub 4 is negative 1 over 256. Now I'm actually going backwards. That means I can't multiply by negative 3/4 again. I need to divide by negative 3/4, which means I'm actually multiplying by negative 4/3. So that is going to give us, so negative times negative is a positive. That is going to be 64 over 3. Then I'm going to keep multiplying by negative 4/3. Oh, actually, I had it backwards. That's 64 times 3. It's actually 1 over 192. And I keep multiplying by another by 4 over 3 again. That is going to be negative 1 over, I believe, 144. And then I keep going. And now it's going to be basically 4 times 27 on the bottom. So it's going to be 108. So since that is negative, negative times negative is a positive. So it's going to be 1 over 108. A sub n equals 1 over 108 times, remember to use the original r, which is negative 3/4, so negative 3/4 to the n minus 1 power. That is example 12, and that is everything for 6.8. Thank you.